Greetings and warm welcome, dear audience. Happy weekend. Here we are again. If you don't see us at the regular time, that just know that we might be having some technical issues and all. So lately that we have been missing a few session and we have been postponing. So hope you could tolerate us. And again, welcome to our research series on research design and methods. Today, lecture number 10, it's on data collection methods. So this is very interesting session and we have two parts. Today, we'll be doing part one. Thank you for this. I would welcome our wonderful ambassador, Professor Dr. Rania Lampo from Greece. Welcome, Dr. Rania.
Thank you very much, Dr. Estera. I'm very happy to be here today to conduct together this webinar. It is with great pleasure that I welcome you all to this session, a new session about data collection. Already in the previous sessions we have explored a lot, but today we will dive deeper in this. And why? Because data collection lies at the heart of every research endeavor. And data collection, we could say, it's the bridge between an idea and evidence, between assumptions and conclusions. And without reliable data, research cannot be trusted. And without the right methods, data collection can be flawed or even meaningless. So today we will explore the various techniques used to collect data, from structural surveys and control experiments to interviews, observations, and even digital tools that reflect the realities of our modern connected world. So thank you very much, Elegant Higher Education, and you, Dr. Esther Mala, for this invitation to conduct together the research series. Once again, welcome. Thank you for being here, and allow me to share my presentation, and let's get started.
Yes, please upload your PPT, please.
Can you see now?
It's upload. Yeah. Okay.
Can you see the change of slides also?
No. It's uploading, I think. Can you hear me?
Yes. Can you?
It's uploading. Okay. It's. Can you please move your slides?
Wait a minute.
Can you move your slides?
Can you hear me now better?
Yeah, I can hear you better now. Can you please move your slides?
Can you see the change of slides?
Yes. Yeah.
Okay,
You're good to go.
Thank you.
Yes. Please.
So the main types of data collection methods which are used in research are typically divided into broad categories. Already we have mentioned this in previous sessions in details: qualitative methods. On one hand, we have discussed about qualitative data collection methods, which actually focus on collecting non-numerical descriptive data to explore concepts, experiences, or social phenomena. Here we have interviews, one-on-one or group conversations that provide in-depth insights. We have focus groups. What are focus groups? Guided group discussions to explore attitudes or perceptions, and observations, recording. Usually these include recording behaviors or events as they naturally happen. They document the content analysis, how we examine text, images, videos, or media for themes, and case studies, detailed examination of a single subject, group, or event. On the other hand, we have quantitative data collection methods, which involve collecting numerical data. Service questionnaires our questionnaires are structured sets of questions, and often with closed-ended responses. Experiments, control studies to test hypotheses by manipulating variables. The structured observations, systemic recording of specific behaviors of events using predefined criteria. So before we have observations, now we have structured observations and existing data or secondary data using pre-collected numerical data, such as census records or databases. And of course, if we combine qualitative and quantitative approaches and methods, we can gain a comprehensive understanding of a research problem. So mixed methods are always considered as the best. So how these methods differ? The purpose of a qualitative research is to explore attitudes, motivations, experiences. The analysis, usually thematic, narrative, content analysis. The strength is that it provides depth, context, and insight into complex phenomena, and the limitations that it can be sometimes time-consuming and harder to generalize, so it's more subjective. On the other hand, quantitative data collection methods, numerical and measurable, so it is the nature of data. The analysis about statistical analysis, the strength here is that it allows generalization to larger populations, so it's more objective and easier to compare. And limitations, this may miss context or meaning behind the numbers. So when it is appropriate to use surveys compared to interviews? This is a good question. Choosing between surveys or interviews depends always on your goals, on the type of information you need, and practical considerations like time and resources. So when to use surveys? When you have large groups, when you want to collect data from many people quickly and efficiently, you will use surveys. When you need structured, quantifiable data that is easy to analyze statistically. When you want to identify patterns, preconceptions, or common opinions across a broad population. When respondents might be more honest if their answers are confidential. And when you have constraints on time, staffing, or budget. Some examples, for example, you want to measure the student satisfaction with a course, or you want to gather demographic info, or you want to assess general attitudes or beliefs. On the other hand, when to use interviews? When you want rich, detailed insights, stories, or explanations. When you want to explore nuanced opinions, motivation, experiences, or complex topics. When you work with a small group of or key stakeholders. When you want to probe deeper or clarify answers on the spot. And about sensitive topics, when a personal empathetic approach is important. Some examples, if you are interested in understanding why students struggle with a concept, or if you want to explore teachers' perspectives on a new curriculum, if you want to investigate specific experiences or challenges, then you're going to use interviews. So here is a summary table in terms of sample size, large and small, quantitative, qualitative, so structured, quantitative, open-ended, qualitative. The time cost lower per respondent, the survey is higher per respondent. We say that it is time consuming and qualitative. And the depth of info is broad but shallow, deep and rich in interviews, flexibility, fixed questions. On the other hand, with interviews, we have more adaptable questions, and the anonymity. This is another issue. Usually anonymous surveys are usually anonymous, and interviews are usually identifiable. Now, how we can design data collection instruments? What factors we should take into consideration when we design a questionnaire? Several important factors. First, we need to clarify why we're conducting the survey. Identify the specific information you need to gather. Ensure that every question aligns with your research goals. Then the target audience. Try to understand who your respondents are, the age, education, culture, language, proficiency, and design questions that are appropriate and understandable for this audience. The question types. Choose between open-ended, qualitative, and close-ended quantitative questions, depending on the data you want. So here we need to use clear and concise wording and avoid leading, loaded, or double-barrel questions. Then, about the question wording clarity, you need to use a simple and unambiguous language, always simple language in questionnaires. Avoid jargon, technical terms, or complex words, and try to keep questions neutral to avoid biasing responses. Then the question order and flow, because you need to start with easy and engaging questions to encourage participation. Then try to group similar topics all together. Avoid sensitive or difficult questions at the very beginning, and also try to use a logical sequence that feels natural. The response options. This means that we need to provide exhaustive and mutually exclusive options for closed questions. We can use balanced scales, for example, Likert scales with equal positive and negative options, and include not applicable or don't know options if this is appropriate. So response options. The length of time, keep the questionnaire as short as possible to avoid tiredness. Try to estimate the time it takes to complete and communicate it clearly. Ensure a clean, readable layout, so use clear instructions. Design for the medium, online, paper, mobile. And pilot testing. This means test the questionnaire on a small group similar to your target audience. Try to identify confusing questions or technical issues or timing problems and revise based on feedback. And some ethical considerations, try to ensure confidentiality and anonymity. Try to obtain informed consent, of course, if it's required, and be transparent about how data will be used. Now, if you start an interview, how can you ensure that interview questions are unbiased and open-ended? Ensuring that these questions are open-ended and biased is key to getting honest, detailed, and meaningful responses. So first, you need to avoid leading questions. For example, don't suggest an answer or imply what the right answer is. Instead of saying, don't you think this product is really effective? Don't say this. You should say, what are your thoughts on this product? So avoid leading questions. Use neutral language. Avoid emotionally charged or judgmental words that might influence the respondent. Instead of saying, why do you fail to meet deadlines? You could say, what can you tell me about your experience managing deadlines? Be culturally sensitive and inclusive. So avoid assumptions based on stereotypes, background, or identity. Try to phrase questions so anyone can relate or respond. Instead of saying, how do you balance work or family as a mother? You could say, how do you balance different responsibilities in your life? Avoid double-barrel questions. Don't ask two things at once, which can confuse respondents. So instead of saying, how do you like the training and the work environment? You can say, what are your thoughts on the training? And then, what do you think about the work environment? Then how to make interview questions open-ended. Start with what, how, or why, because these words invite elaboration rather than a simple yes or no answer. For example, what challenges have you faced in this role? Try to encourage storytelling and explanation. So ask, for example, experiences or feelings. So you can ask, how can you describe a time when you overcame a difficult problem? Avoid yes or no multiple choice formats unless used as a follow-up to dive deeper. So instead of saying, do you like this method? You can say, how do you feel about this method? And use problem follow-up questions to deepen understanding after the initial answer. For example, you can ask them, can you tell me more about that? What led you to this conclusion? Now, what role does a pilot play in developing data collection tools? Pilot testing plays a crucial role by helping to ensure the reliability, validity, and overall effectiveness before full-scale development and deployment. Why this is important? Because pilot testing reveals unclear, confusing, or misleading questions or items. It helps spot technical problems in service, in interviews, or software tools, and of course, it allows refinement of wording, instructions, or formatting. Then, it checks if the tool accurately measures what it tends to, the validity that we have mentioned in previous sessions. It evaluates consistency of results over time or across different responses, the reliability. and defines if the tool is user-friendly, is easy to administer, it assesses the time required for data collection, and it identifies logistical or resource constraints, so we can test the practicality and feasibility, improve data quality. So this helps detect potential biases or systematic errors. It ensures that questions elicit the intended types of responses. And of course, it highlights problems with response scales or categories. And of course, pilot testing can serve as a rehearsal, allowing those who administer the tool to practice and provide feedback. Finally, it provides initial data that can be analyzed to make early adjustments, so it helps define if the tool captures useful, actionable information. So pilot testing acts as a trial run that helps developers refine data collection tools to be clear, accurate, and practical, ultimately, this way improving the quality and usefulness of the data collected. Now, I think in the previous sessions we have explained some types. Now we're going to mention, we can clarify more concepts and more types. The purpose of sampling research is to select a smaller manageable group, so a sample, from a larger population that accurately represents the population. So this allows researchers to make inferences, so draw conclusions about the entire population without studying everyone. You can save resources, reduce time, cost, and effort compared to serving the whole population. You can improve feasibility, so enable practical data collection when the population is large or inaccessible. Enhance accuracy. When done properly, a good sample can provide reliable and valid results that reflect the population's characteristics and facilitate analysis. This means the purpose here is to manage and analyze data more efficiently with a smaller data set. In short, we could say that sampling helps researchers study a portion to understand the whole. So another question is, how does sampling affect the generalizability of research findings? How well research findings can be applied beyond the study group? How? By the representativeness of the sample. If the sample accurately reflects the characteristics of the larger population, findings are more likely to generalize well. On the other hand, if the sample is biased or unrepresentative, findings may only apply to the specific group studied and not beyond. The sample size. Larger samples tend to provide more reliable and stable estimates, increasing generalizability. On the other hand, very small samples may not capture the diversity of the population, limiting the applicability of results. The sampling method. Random sampling means every member of the population has an equal chance of selection. So this maximizes generalizability, of course. And no random sampling, this risks biases and reduces generalizability. The sampling frame is the list or source from which the sample is drawn. Must cover the target population well. If parts of the population are excluded from the frame, the findings may not generalize to this group. So here we can see summary table, the sampling factor, and what is its effect on generalizability. More representative sample, high generalizability. Larger sample size, more reliable. Smaller sample size, less reliable. The random sampling method, better generalizability. No random, less generalizability. And the sample frame, it is complete and incomplete. The complete means better coverage, and incomplete sample frame means limited. The better the sample process approximates the overall population, the more confidently researchers can apply the findings to a wider group. So poor or biased sampling narrows the scope of applicability. I guess you understand the difference between sample and population. Population is entire group of individuals, of items, of data you want to study. It includes every member that fits your criteria and often is too large or impossible to study completely. for example, all high school students in the country. On the other hand, sampling is a subset or small group selected from the population. So it is used to represent the population when studying everyone is impractical. And ideally, the sample should be representative so findings can generalize to the population. Example, 500 high school students randomly selected from different schools across the country. So here are some key points about what is happening with a population and a sample. Now, what are the differences between probability and non-probability sample methods? Sample methods are used in probability sampling when every member of the population has a no zero chance of being selected. So random selection is involved, generalization I mentioned before, and the common types that you need to know about probability sampling is the simple random sampling, the systematic sampling, stratified sampling, cluster sampling. One of the advantages of this type of sampling is that the results are more representative of population. This supports statistical inference and hypothesis testing. And on the other hand, what are the disadvantages? That it can be time-consuming and costly, and that it requires a complete sampling frame, so the list of population members. On the other hand, the no probability sampling methods, here is the probability of selecting each member. The probability of selecting member is unknown or zero. So selection is not random, cannot reliably generalize results to the entire population. Sample error cannot be calculated. And what are the common types of no probability sampling that you need to know? It's convenience sampling, judgmental or purposive sampling, snowball sampling, quota sampling. I want to explain all these types. What are the advantages of this type? It's that it's easier, faster, or cheaper to conduct, that is useful for exploratory research when a sample frame is unavailable. And what are the disadvantages? There are higher risks of bias and no representativeness, limited ability to generalize findings beyond the sampling. So here is the differences. And how does random sampling improve the reliability of data? Of course, by making sure that every member of the population has an equal chance of being selected. This helps in several ways because the sample is chosen randomly. It is less likely to be altered by any particular group of characteristics. This means that the sample better represents the entire population. It enhances representativeness because a random sample is more likely to reflect the diversity and variation within the whole population, which makes the data more generalizable. If the sample process is repeated multiple times, then random sampling tends to produce similar results, which boost the reliability, so the consistency of the data, and it allows for statistical validity because many statistical tests and confidence intervals assume random sampling. Using random samples lets researchers apply these methods to estimate the accuracy and precision of their findings. So this, we could say that random sampling helps ensure that the data collected is both fair and dependable, making conclusions drawn from it more trustworthy. Now, what is purposive sampling? This is useful when the research requires selecting specific individuals that can have particular characteristics or knowledge relevant to the study. So when a purposive sample is more effective, when we want to target a specific subgroup or experts, for example, when you need participants with specialized knowledge, experience, or characteristics. For example, you want to interview climate scientists for a study or environmental policy. When you want to conduct exploratory or qualitative research, so when depth and detail are more important than generalizability, so researchers deliberately select cases that are information rich to gain deeper insights. When the population is small, specific, or difficult to access, so we talk about limited or hard to reach populations. For example, you want to study survivors of a rare disease or members of a niche community. When a random sample would include many relevant participants or fail to capture necessary diversity. Purposive sampling saves time and resources by focusing only on relevant participants. So, on the other hand, simply random sampling is best when you want a representative, generalizable sample from a large homogeneous population, and this ensures that every member has an equal chance of selection. So, in summary, we could say that purposive sample is more effective when we need specific information-rich cases rather than a generalizable sample, especially in qualitative or targeted research contexts, and this prioritizes relevance and depth over randomness. So, these types that we mentioned, probability, no probability, probability sample systematic cluster stratified, no probability is noble, quote, and convenience. The random sample, we already mentioned about this. So what is the difference between random sample and systematic sample now? The random sampling is that the advantage of this is that minimizes selection biases, and the disadvantage that it can be time consuming. So every member of the population has an equal chance of being selected. On the other hand, with a systematic sampling, the researcher selects every individual from a listed population at regular intervals. And what is the process? After randomly selecting a starting point, samples are picked systematically. For give an example here, from a list of 1,000 people, selecting every 10th person, starting from the 7th name. So what is the advantage? Is that, of course, it's easier, faster to deliver than a single random sampling. And of course, the disadvantage is that it can produce bias if there is an underlying pattern in the population list that actually coincides with the sample interval. So this needs, of course, to be careful. So random sampling relies on chance alone for its selection. Systematic sampling follows a fixed regular rule after a random start. Now, the different, what is stratified sampling work? Stratified sampling is a sample technique designed to ensure that specific groups called strata within a population are adequately represented in the sample. So how this works? Here we try to divide the entire population into distinct, non-overlapping groups, what we call strata, based on the key characteristics: age, gender, income level, grade level. Then we randomly select participants from each stratum. The number chosen from each group can be proportional to the stratum size in the population, so proportional stratified sample, or equal regardless of size, equal allocation. Then we combine the samples, so combine the samples from all strata to form the final sample. So if you want a sample representing the school students, where 60% are female and 40% male, you will divide the population into two strata, females and male. You should randomly select the 60% of your sample from females and 40% from males. And this ensures that the sample reflects the gender distribution of the school. So when this is stratified sampling is useful, when you want to ensure all key subgroups are represented, so when population is heterogeneous, when you want to, for example, to compare opinions by age or gender, so when subgroups comparisons are important, when you want to avoid under or other represented any group, so when proportional representation is critical, and when stratification can reduce sampling error compared to simple random sampling, so when overall precision needs improvement. So what are the benefits? The benefits is that actually this improves representativeness of the sample, allows for meaningful subgroup analysis, and of course this increases precision and accuracy of estimates. What are the benefits and drawbacks of now cluster sampling? What is cluster sampling? Cluster sampling, the population is divided into groups, clusters, and entire clusters are randomly selected for study instead of individual members. What are the benefits? That it's easier and cheaper to collect data from entire clusters, especially when the population is large and spread out geographically. That it's convenient because it simplifies logistics by focusing on groups rather than scattered individuals. It is practical for large population because it's useful when a complete list of individuals is unavailable, but a list of clusters is. And because it reduces travel administrative burden, so metadata collection is concentrated in fewer locations. And what are the disadvantages? That higher sampling error, this higher sampling error compared to simple random sampling because individuals within classes tend to be more similar, homogeneous. So there's less precision. And if selected clusters don't represent the diversity of the whole population, results may be biased. So the risk of bias if clusters are not representative. This requires larger sample size. In order to achieve the same level of accuracy as a simple random sampling, you often need a larger total sample. And the data analysis must account for clustering to avoid incorrect influences, for example, using specific statistical techniques. Now, when would you use convenience sampling now? You will use convenience sampling, of course, despite its limitations, in situations where practicality and speed outweigh the need for strict representativeness. We could say some common reasons and scenarios. When to choose convenience sampling? When you are, for example, in the early stages in your research and you want to gather preliminary insights or generate hypotheses quickly, so for exploratory research. When time, budget, or access to a full sample frame is limited, convenience sampling is often the most feasible option, so when there are limited resources. When we want to test research instruments like questionnaires or interview guides before conducting a larger, more rigorous study, so pilot studies. For hard-to-reach populations, if it's difficult to identify or access a complete list of potential participants, you might rely on those who are readily available. Or for educational settings, when you work with students in a specific class or group where random sampling isn't practical. And when you just need quick feedback or initial options, opinions, on a new product or a service or a concept, then, so in general, when you want feedback or idea generation. So what you need to remember that while it is convenient, the results from convenience samples can be confidently generalized to the broader population due to selection biases. So findings should be interpreted here with caution. Now, how do you define an appropriate sample size for a study? So the sample design and execution it's something very important, and this depends on several factors that balance accuracy, resources, and study goals. So what are the key factors? But if first the population is small, then you might need a larger percentage of it. For very large populations, the size stabilizes and doesn't increase much beyond a point. The margin of error, what we call confidence interval. This is how much error you are willing to accept. Smaller margins of error require a larger sample size. For example, a 3% margin of error needs a bigger sample than 5%. The confidence level. This reflects how sure you want to be about your results. Commonly, this is 90%, 95%, 99%. Higher confidence levels require larger samples. If the population is very diverse or responses vary widely, then you need a larger sample to capture this variation accurately, so variability in the population. And study design analysis types are complex analysis or subgroup comparisons that usually require bigger samples. So what is the common approach to define sample size, to use sample size formulas, or to use sample size calculators, online tools or software that let you input confidence level, margin of error, population size to get a number. A pilot study, because sometimes a pilot study helps estimate variability and refine sample size. So a summary, you want a sample large enough to be representative and precise, but not so large that it wastes time and resources. Balancing confidence level, margin of error, and population variability is the key. And what are the factors that influence the choice of a sampling technique? The choice of sampling technique depends on important factor here that shape how and why participants or data points are selected. For example, the research objective questions. What you want to learn affects sample choice. Exploratory qualitative studies often use proposing or convenience sampling. Quantitative generalized sample studies typically use probability sample like simple random or stratified sampling. Then the population characteristics. Size, diversity, and accessibility of the target population matter. Large homogeneous population suit random sampling. Small, specialized, or hard-to-reach groups may require proposal or snowball sampling. When there are resources and practical constraints, time, budget, and manpower affect what is feasible. Random sampling can be costly and time-consuming. Convenience or purposive sampling may be chosen for efficiency despite lower generalizability. The desired level of precision and representativeness. If representativeness is critical, for example, for statistical inference, then probability sampling is preferred. For in-depth understanding or specific insights, no probability sampling is sufficient. For sample frame availability, whether a complete and accurate list of the population exists, this affects the method. If there is no reliable sampling frame available, then proposal or convenient sampling might be used. And of course, we talk about ethical consideration here that vulnerable populations might require sensitive sampling approaches, and also concern confidentiality and fairness impact technique choice. So what is the nature of data here? The quantitative data collection often favors structured probability-based sampling, and qualitative data collection allows more flexibility with non-probability methods. Choosing a sampling technique involves balancing research goals, the population characteristics, the resources, the ethical concerns, and desired data quality in order to select the most appropriate method. And a sampling error impact research results because sampling error occurs when the sample selected does not perfectly represent the entire population. This can lead to estimates that differ from the true population values, making results less accurate. Although sampling error itself is random, if the sample is small or not well chosen, the sample might systematically differ from the population in ways that bias the results. Sampling errors also increases the variability or uncertainty around the estimate. This means repeated samples could give different results reducing confidence in findings. Then misleading conclusions. If the sampling error is large and not accounted for, researchers might wrongly conclude that the treatment relationship exists or fail to detect one that does exist, type 1 error or type 2 error. And the high sampling error makes it harder to generalize findings from a sample to the whole population, limiting the usefulness of the research. So in summary, we could say that sampling error introduces uncertainty and potential inaccuracies in research findings. So it's important to minimize it by choosing an appropriate sample size and sampling method, and to report its impact through statistical measures. So what are the steps that researchers can take in order to reduce this sampling bias? Now, sampling bias happen when certain members of the population are more likely to be included in the sample than others, leading to results that are not representative. So how we can reduce this? We can select participants randomly from the entire population to give every individual an equal chance of being included. Use stratified sampling, as I mentioned before, or quota sampling to ensure that the sample reflects the key characteristics, age, gender, ethnicity of the population. Larger samples tend to reduce the impact of bias and increase representativeness. Avoid sampling only easily accessible participants unless the population is homogeneous and accessibility doesn't introduce bias. Try to use multiple sampling methods. This means combine different sampling techniques. This can help capture a more diverse and representative group. Try to define the population clearly define the target population in order to avoid including ineligible participants or excluding relevant groups. Pilot testing, try to conduct a pilot study in order to identify potential biases in sampling and adjust the methods accordingly. And check for no response bias. This means follow up with no respondents in order to analyze differences between respondents and no respondents to minimize biases caused by differential participation. In general, try to use frames carefully. So use up-to-date and comprehensive lists or databases to select samples and avoid outdated or incomplete frames. And document sampling methods thoroughly so others can assess the potential biases and replicate the study. The snowball sampling here, we haven't mentioned it today, is a no probability sampling technique which is often used in quantitative research when we want to study hidden or hard to reach populations. So how this works? When the researcher identifies and recruits a small number of initial participants who meet the study criteria, so the initial contact, then the participant referral. These initial participants are then asked to refer others they know who also fit the study criteria. And the chain referral. Each new participant is in turn asked to refer others. So the sample grows like a snowball. This is why it's called snowball. The sample grows like a snowball as each wave of referrals brings in more people. When this is most effective in contexts where populations are difficult to access or they do not have a sample frame which is available. For example, the drug users, the sex workers, people with rare diseases, undocumented immigrants. When trust is essential, referrals from peers can increase willingness to participate in studies on stigmatized issues, and network connections, when network connections are relevant to the research question, for example, social networks or community dynamics or informal support systems, and etc. What are the limitations? That the sample may not be representative of the larger population because it relies on social networks, because participants often refer people similar to themselves, which can limit diversity, and the sample can be altered by the characteristics of the first few contacts. Common research contexts in public health, to mention about these groups in sociology, we have gangs, for example, the ground economies, in criminology, and in anthropology, when we have secluded groups, etc. Now, we haven't mentioned about quota sampling and how this differs from stratified sampling. Both of them, quota sampling and stratified sampling, are both techniques which are used in survey research in order to ensure representation from different subgroups or from population. However, they differ in how they select participants. For example, in quota sampling, what is happening here? Researchers divide the population into subgroups, age, gender, income, for example, and then they select a predetermined number, quota, of participants from each subgroup. Participants are chosen randomly. This is based on convenience or judgment. And I'll give you an example here, but if a study wants 40% of males, 60% females, researchers will continue recruiting people until they have these proportions. But may stop people in the street until the quota is met without random selection, as I mentioned before. What is the difference with stratified sampling? In stratified sampling, we said that the population is divided into strata subgroups, and random samples are drawn from each stratum. This is the difference. Here, participants are chosen randomly within each stratum, ensuring that each subgroup is fairly represented in the final sample. So if, for example, a population is 40% male and 60% female, and the sample size is 100, researchers randomly select 40 men and 60 women from the overall population. And here is the comparison group. Here we can say the last, I think, yes, this will be the last type for today. Multiple stage sampling, which is practical and efficient technique, which is often used in large-scale surveys, especially when the population is geographically dispersed or too large to list entirely. So here, this is a complex form of cluster sampling, where sampling is carried out in multiple stages, using progressively smaller units of each stage. So here, instead of selecting individual elements of the populations, you can divide the population into primary sampling units, then sample from within these units, and then continue sampling from smaller and smaller units, households, individuals, etc. So first regions, then we have towns, villages, and we have individuals. This is the multi-stage sampling. So what are the steps here in using this sampling? Is first of all, we need to define the population. The first stage is to select the primary sampling units I mentioned before. These are large areas of clusters. The method is that we use often random stratified random sampling. Then the second stage is that we select the secondary sampling units. Then we select the final sampling units, and we conduct finally the survey. So this could be interview or survey the final sampling units. So what the advantage is that it's cost efficient because it reduces the cost of traveling and data collection. It's feasible for large and dispersed populations. It's flexible because different sampling methods can be used at different stages, and it reduces administrative complexity compared to listing the entire population. So an example in practice, for example, in National Health Survey, we could say the first stage is to select 100 districts across the country. The second stage could be within each district, we randomly select 10 villages or urban blocks. The third stage, from each village now, we randomly select 20 households, and from each household, we select one adult to interview. This is what we call multi-stage sampling. This allows reaching thousands of individuals with manageable logistics and representative results. So I will stop here.
Yes. I think we have gone through exactly about an hour. Okay, thank you so much, Dr. Rania. Very, very insightful, very, as usual, well narrated, and you very good explanation of your PPT. I'm very sure our audience would have gained much, and it's also for me. I'm also following you, so hope to meet you again in next session on coming next week Thursday, part 2. Yeah, dear audience, thank you so much for your time, and thank you so much for your support. And I really believe that that you would have enjoyed this session much, and continue to support us and learn from us. It is offered free for you. So see you again. Have a fantabulous weekend. Thank you. Bye.
Thank you very much.